Good evening, everyone. Welcome back to the Astro Imaging channel. I hope all of our U.S. viewers had a nice Thanksgiving holiday last week, and everyone's hopefully having a nice holiday season so far. We've got another great show for you tonight. Timothy Martin is back, and he's going to give us a processing demonstration with NGC 1333. So I'm looking forward to seeing that. But before we get into the presentation, just let me talk a little bit about the upcoming calendar. I'll pull that up here. Share that. So as you can see, we've got a pretty good slate of guests coming up over the next couple of months. Tonight, Tim is here, and then next week, Alistair Simon will be here to talk about this amazing mosaic that he's worked on and recently finished. Alistair's here tonight, so he'll give us just a little taste of that in a moment here. Then just note, we've got 2 weeks off for Christmas and New Year's. We won't have a show either of those weeks, so we will be, after next week, we'll be off for the rest of the year. Then we'll be back on January 5th. Tsuchinshan-ATLAS will be here to talk about new image processing tools that they've come up with. And then Cheryl Wilcox will be with us. She's got some really neat nightscape, Milky Way nightscape photography to tell us about. Alan Friedman will be with us about solar imaging. Dustin Brimbury will tell us some more good stuff that we need to know about Nina. And another presentation about the eclipse. We've got no show on the 9th because it's the Super Bowl. And then Rolf Olson will be here to talk about a really long Centaurus A project that he's been working on for 10 years. So good slate of guests, as I mentioned, but then after that, we are open. So as always, anybody, if you have been thinking about a topic that you might want to present, please drop us a line and we'll get you on the show. So, all right. So as I mentioned, next week's guest, Alistair Simon, is here tonight, and he's going to give us just a brief preview of next week's presentation. Simon, can you tell us a little bit about that?
Yeah, thanks, Patrick. Yeah, so next week I'll be going through a project that I've worked on probably for about 4.5 years. Didn't start out to work on a 4.5-year project, but I eventually found that that's where I ended up. But over that period of time, I'm going to show you how I used different resolutions of imaging, be it camera lenses, be it 4-inch refractors, and all the things in between, to take images that you can then combine into a huge mosaic of the entire northern Milky Way. And that's beyond just what you can see in the summer Milky Way. It also incorporates the part of the northern Milky Way you can see in the winter. So that's the benefit of doing it over several years, as you get to image all the different parts of it. And I'll be explaining some of the challenges involved in that. It's a narrowband image. It's fairly high resolution for the Milky Way. It's 135 millimeter camera lens resolution. And it comprises about 200 images and about 2,000 hours of light gathering over that period of time. But I'll go through the challenges that's involved in that and some of the techniques that I've used that actually help you do it with less time than you might think it would take. Even though it's 4.5 years, to do it in a more traditional way would take even longer. So that's what I'll be going through.
All right, well, that's going to be fascinating. And I've seen the image. You've got it posted on your website, and I think maybe on Astrobin as well. It's amazing. So it's really going to be interesting to hear the details of how you put that together. And I can imagine there have been all kinds of challenges over that long of a period of time, 4.5 years, multiple cameras, probably different equipment changes and whatnot. So yeah, that will be really interesting. So we will be looking forward to that next week.
Thanks.
So that brings us then to tonight's presentation by Timothy Martin. And regular viewers of the channel will know that Tim has been kind enough to appear here on the Astro Imaging channel a few times over the last year. First, he told us all about his astrophotography journey and lessons he'd learned getting into the hobby over the last few years. Then a few months ago, he came back and showed us how to set up Nina for remote imaging. So tonight, we sort of bring all that together with the processing demonstration of NGC 1333, which is a really cool object, also challenging though. So we'll be looking forward to seeing how he managed to do such a nice job on it. So Tim, if you are ready, I'll turn it over to you.
Okay, yeah. Thank you so much, Patrick, and thanks for having me. And hey, everybody, and hope you're all having a great holiday. Just want to, one proviso is I'm no expert at this stuff. We've had this conversation. I'm just a guy who is doing the best he can. So if you're looking for me for expert advice, don't. But this is just these are just things that I've learned from other people, and primarily from lessons with folks like Ron Breacher and talking with Warren Keller and other people and watching what other people do. So we'll just jump right into it. I won't bore you with too much background. So we're looking at PixInsight here, and I've got all my masters up here in the upper left corner. Here's the luminance master. So this is about, I can't remember, 40 or 50 hours total on this object, NGC 1333. It's one of those objects that photographs well at a wide angle and at a higher focal length. So it's a really good subject for either one. This is kind of in between. This was taken with a TOA130. Got a picture of the telescope that took this image here. Here it is out at Deep Sky West in Santa Fe. So sitting on a GM2000 mount, I used a Moravian C5a-100M camera. So medium format sensor, pretty large sensor. So these masters are very large. You can see pretty much 12,000 by 9,000 pixels. So that requires, a lot of processing power to stack all that and to store all that data. But it's worth it. I really like the big wide field with the TOA. It creates a lot of options that I normally wouldn't have. So I've got this luminance master, and I've got my red, green, and blue masters. Now I stack with Astro Pixel processor. I don't use WBPP. Part of it's just laziness, not wanting to learn something new. But I have done some comparisons, and for me, the way I do it, maybe I'm not doing it right. I seem to get a little better results with Astro Pixel processor. As I was telling Patrick earlier today, some words I never thought I would say is that the PixInsight user interface for stacking is far better than the Astro Pixel processor interface, but it does do a nice job. So that's how I stacked it, and that gives me FITS files, not XISF files. So I've got FITS files sitting out there, and the first thing I'm going to do is create a superluminance master from the luminance red, green, and blue masters. And to do that, I just use the image integration process. And everything is pretty much at defaults, except you want to make sure that under pixel rejection, you've got no rejection, and uncheck this generate rejection maps. You don't really need that. So everything else is pretty much defaults on this particular process. Then I will go out and add the files. I'm going to click on the luminance master and set that as the reference. And then normally I would click the apply global button here on the process, but then we'd have to sit through it stacking those 4 images. That takes a few minutes. So I've already done that. and it's right here. Kind of hard to see any particular difference here, but we can run an image analysis on this and look at the signal to noise ratio. So here's the original master, and we can go to script, image analysis. If I can find it, there it is. And SNR, we'll run that. It just takes a minute to run. And what we'll see is quite an improvement in signal to noise ratio. Now we're running that on the superluminance that we created. And you can see about a 5 decibel difference between the original and the superluminance. So it's worth doing. This was something that Ron showed me some time ago, and I've been doing it ever since. So after having done that, I'll rename this image to LUM.org. And I'm not gonna make you guys sit through all these processes. So I've already done all the processing. I'm essentially gonna be clicking through the history of each of these images as we go along. And I'll show you the processes that I applied. So I just renamed this to LUM.org. I'm not gonna be using it again. And then I renamed this to LUM. This is kind of important because some of my processes already have names built into them. I've saved these icons out with names built into them just to make things a little more convenient to run. And so then I'll do a similar thing on red, green, and blue. I'll rename the red just to R, green to G, blue to B. And then the next thing I would do is crop the images. So typically use the luminance as a reference for cropping, not necessarily always. I guess it depends on when I shot, what I shot, and how well things were lined up. So I would use dynamic crop for that. And just move these lines in. One thing to note here is I don't want to crop right in the middle of that star right here on the upper edge. So it's either leave it in or take it out. And I want to make sure I'm past any stacking artifacts. So I'm going to crop past that. And then normally I would just hit the checkbox. First, though, I would take the little triangle, this perfectly intuitive triangle, and drag it onto my desktop here so that I preserve this crop and I can apply it to the other images. And then I would click the checkbox. But since I've already cropped this image in its history, I won't do that. So now I'll prove that I've done that. And so now you can see where I cropped that. So I'll put that one away. I had also cropped the red. Green. And the blue. And then the next step is I'll just create an RGB image from the RGB masters. So I do that with channel combination. And I would click the global apply global button here as well, and that would combine RGB into a full color master image. I've already done that. It's right here. It's already cropped and ready to go. And then I would rename this I could double click here and change the name, but since I've already done it, I'll just move through the history. And now I've called that RGB. So then the next step, I held on to DBE for a long time and still use DBE quite a bit for background extraction. But on certain images, and this is one of them, where there's just a ton of nebulosity everywhere, and I don't want to background extract nebulosity, I tended towards Graxpert. So I'm going to use that on the luminance and the RGB masters here. And I just use default parameters here. Once I've got Graxpert all set up, I use default parameters here and use subtraction typically. If I was using the C11, I tend to get artifacts from the scope itself, and I would use division on that as well as subtraction. But here I think subtraction is all that's needed. And once again, I've already done that. So I'll just show you the result. Not a whole lot of difference. You see, it got a little lighter in the corners where it was dark. Same thing here. I've already done it here. And so I'll apply Graxpert here. You see quite a bit more lightness here. Then next up on the RGB master, I will use Blur Exterminator with correct only checked. This is Russ Croman's recommended step to correct the star shapes before doing any color calibration. So normally I would just drag that over and drop that on there, but I've already done it once again. So I'll just move through the history, and now we can see. And the TOA does a pretty good job in the corners. Correct only doesn't do a whole lot of correction. If I go back and forth, you don't see a tremendous amount of difference. This is before and after. So not a whole lot of correction to do there. So once that's done, then I will do color calibration on the RGB master. And I tend not to use SPCC. One of the reasons is because I'm stacking an Astro pixel processor, I don't have the coordinates data built into these masters. And so I'd have to use the image solver to do that. And that can be kind of cantankerous at times. And then I've also had, maybe it's something wrong with my computer or my software setup, but I have SPCC locks up on me about 50% of the time. And so then I just have to kill PixInsight with Task Manager and start over from the very beginning. So, and also Ron has recommended just use regular color calibration, so I tend to do that. And I just use the defaults, except for here in background reference. I find a preview. I try to find it as dark a spot with as little going on as possible, and no stars, particularly no bright stars, and create a little preview window. And then this process is ready to go. So normally I would just drag this over and drop it on there, but since I've already done that, I will just click to the next step in history. And so now that image is color calibrated. And then next I will run Blur Exterminator in its full glory on these two masters. For the sharpened stars, I typically use a value of 0.5. I think that's the default. And then on the TOA, I typically ramp the sharpened non-stellar all the way up. It doesn't tend to do a whole lot, and we'll see. We'll look at a comparison of before and after here in a moment. On scopes with a longer focal length, I'll ramp that back. 60, 70 to 0.6, 0.7, 0.8, just to avoid any artifacts or worminess or anything like that. So I will go ahead and apply this. And the same here. We can go. Yes, sir.
I see you're using the history tab quite a bit. You want to just bring that up for a moment? I'm sure most everyone knows about it, how you can go back through the history.
Yep.
So you're stepping through by using the back button or the forward button.
The forward button, yeah.
Yeah.
So everything that I've done to these images has been stored in the history, and I can navigate through that here. I can even double click here and jump to a step way down the line. But these two buttons move you forward and backward through the history. And so that's what I'm doing just to save time, because especially on these images from the C5 that are so big, some of these processes take quite a while. Even with CUDA acceleration and all that, some of these processes can take quite a while. So rather than make you guys sit through that, we're just kind of fast forwarding through it. So here we can take a look at what we have before Blur Exterminator and after. So even with sharpened non-stellar ramped all the way up to the top, it's really kind of a modest change. Not a whole lot going on here. I think that's more attributable to the fantastic engineers at Takahashi than it is to anything else. Same here. We can look at this at the luminance as well. This is before and then after. Before, after. So I don't want to leave the impression that I just ramp up sharpening and star reduction and everything to the maximum. There is some method to this madness. So the next thing I would do is clone this RGB master, because I'm going to use that for the stars. And I can just do that by dragging the tab off, this left-hand tab off of the image onto the desktop, and that creates a clone. But I had already done that, so I'll close this and open that clone. So at this point, these two masters are identical, but that's soon to change. I'll tuck this away, this momentarily. Oh, actually, wait, before I tuck it away, I'm going to rename this RGB stars, because I'm going to use it for my stars. So I've named this RGB stars, and we'll get back to it. So then the next thing I will do is run Star Exterminator and remove the stars from both these masters. And in that case, I'm not going to generate star images from either one of these. So I leave that box unchecked. But I tend to just leave the large overlap box checked all the time. I've seen artifact issues when it's not checked on various images. Sometimes I get it, sometimes I don't. So I just leave it checked all the time, and I rarely, if ever, see any artifacts as a result of star removal when I have that box checked. So normally I would, again, just drag the triangle onto the image and kick off the process on that image. And I would do the same for the RGB master. But since I've already done it, and that's a fairly lengthy process. So we're saving quite a bit of time by just going through the history here rather than sitting through it, processing all that. So now I have two starless images. And the next thing I will do to those is run noise exterminator. So on the RGB, I'm going to bring up the parameters I typically use for this. On the RGB image, I'm going to ramp up denoising all the way. And add a little bit of sharpening, not too much. I think the default is 0.15, and I tend to either leave it at the default or go up to 0.3, but I don't really care for the kinds of artifacts the sharpening and noise exterminator creates, so I don't tend to use a lot of that. But on the RGB image, I will do the maximum amount of noise reduction. On the luminance image, I'll ramp that back to between 0.6 and 0.8. I want to leave a little bit of natural noise in the luminance image. This is something I've been counseled on by people who've looked at my images and found them to have too much noise reduction. So I'm trying to add back in a little bit of noise, I guess. So I have already done that. I processed this one with a denoise of 1.0. Can't really see much difference there. But then if I run the auto stretch on it again, now you can see quite a bit of difference. And then I ran this one, I believe, with 0.8. And notice how much smoother the luminance is than the RGB, even though I think I got around 7 hours each of RG and B. I think I got around 11 or 12 hours of luminance, and then you factor in the superluminance process, and you're really looking at a luminance image that's the equivalent of 17 or 18 hours. So now these are almost ready to stretch. I also apply max noise reduction to the stars images as well. And we can do an auto stretch on that as well. So
Hey, Tim.
I'm just going to kind of, yes, sir.
Question for you, actually a couple of questions, but there is one question about the luminance, and since you're just touched on that again, before we go away from that. So the question was about the shooting just straight luminance versus the synthetic luminance. And I know you did luminance and synthetic, I mean, essentially, but you're familiar with just making a synthetic luminance without actually shooting separate luminance, correct?
Correct. Yeah, just making that synthetic luminance from the RGB combination.
Right. So have you looked at that, whether the actual luminance itself is adding much, or have you tried it with just the superluminance from the RGB frames?
I have, and I have found it to not be nearly as good as shooting actual luminance, and I mean not even close. It's no contest. It's, for me, it's just no contest. I just had this conversation last week with Lloyd Smith, the owner of Deep Sky West, and he is a big proponent of shooting real luminance over creating a superluminance from RG and B, and really even at the expense of RGB. At some point, you kind of have all the color you need, and what you're really looking for is resolution.
That's part of the benefit of having real luminance, is that you get the signal to noise ratio increase by having a lot more light in the luminance in each individual channel, which I think is why part of the reason why it's such a big boost of having real luminance as opposed to a synthetic one.
Right, right. That makes
There's
sense.
There's a couple other issues with that too. If you're shooting like an HO-RGB image, you can get away with just the RGB image, whether it be
Sure.
a superluminance, a combination, or just RGB, because HO gives you your detail and probably your luminance. But if you make the superluminance, you're increasing SNR, hopefully all the parameters which lead to more resolution. So that's always a good idea. I mean, there's no downside to adding those up, provided the quality of your subs is good. Tim?
Yeah. Sorry, I had to let the cat out of the room. He was
Yeah,
getting
those cats are a bother.
Yep. Yep. So yeah, I think all of that makes sense, and so I shoot a lot of luminance and have been very happy with the results that I get from it. It really does. We're going to see a huge difference when we combine the luminance with this thing, and then it also makes it easier to do the last stages of processing. You can do a lot more with contrast and those kinds of things. It also lets me go to town with noise reduction on the color itself to try to reduce some of the color noise as well as the inherent noise in the color image. So I can really kind of go to the max on noise reduction on the color part of it, and then try to leave the luminance a little more natural and let that give it a more natural look. So any other questions about that, Patrick? Or you said there was a couple of questions.
Oh yeah, those were the questions about the luminance. I was also just wondering, I noticed that you ran Star Exterminator, removed the stars before running Noise Exterminator, as opposed to running Noise Exterminator, removing the noise, and then taking out the stars. Have you noticed a difference doing it in that order? Is it as far as you get better stars maybe in the stars only image, or?
Well, so let me think about this for a second. So I ran Noise Exterminator after I removed the stars from the RGB and the luminance. And one of the reasons for that is if Star Exterminator leaves any artifacts, I want the noise reduction to help take care of some of those artifacts. But then I ran it on the stars. This is going to be my stars only image. And I ran it on here before I extracted the stars. So I kind of did both, Patrick. Does that make sense?
Yeah, it does. I guess I missed that part of it where you changed the order a bit on the stars only one. So, okay.
Right. Because
But
I'm going to go ahead and stretch this before I remove the stars from here.
Okay.
Okay.
Thank you.
Mm-hmm. Let's see, where was I? Okay, we were about to stretch some stuff. So I'm going to kind of go through one stretching process a little bit. I know generalized hyperbolic stretch is all the rage, and there are various other stretching, arcsine H stretch and this stretch and that stretch. I know there's all kinds of different stretching techniques, but something Ron has kind of pounded into me is just to kind of do it the old school way. Maybe it's not that old school to you guys who really are old school, but it is to me. So I'm going to make a clone of this RGB image rather than lose my history. And I'll just go through some of the stretching steps that I go through on this. So I'll start with histogram transformation and turn on tracking, open the preview window for it, and then I'll move the mid-tone slider to the left. I'm going to go ahead and harden that and start again. I'll click the reset button and keep moving it to the left. And now I can slide this to the right a bit. And here's the number I've been taught to watch. This little number 98. As I move to the right, that number will increase. So I'm assuming that's the number of pixels I'm clipping at the bottom end of the image. And then I'll keep moving this mid-tone slider. And then I'll drag my cursor over kind of the brightest part of the image. I don't want to let that get much beyond 0.9. If you look at those numbers on the right-hand side of the little box, you'll see they're in the 80s right now. And I want to stretch it until they get into about the 0.9 area. A little more. And I've got some stuff going up to 0.95. I may back that off at 10. And then I'll harden that. I'll close this histogram transformation for the time being. And then what I'm going to do here is I don't like how blown out this area is. It's going to lose all its color because it's so blown out. You have similar issue over here. And this is VDB 12, I believe, and it's starting to turn a little bit white there. So I want to maintain that color. So I'm going to use HDR multi-scale transform on it. And I'm going to do a very simple application of this. There are times when you may want to create a mask for the bright spots. That's not always necessary. It will automatically mask darker areas if you click the lightness mask. Then I'll click preserve view and to intensity. And I happen to know that 7 works pretty well here, the number of layers. And then I would drag that over here. That'll take a second to execute. So what I'm trying to do is reduce the brightness of those very bright areas somewhat and allow the color to still come through. I'm not quite done stretching yet, so I don't want to blow those areas out as I'm continuing to stretch this image. Another step I'll take here is I will run noise reduction again. Since this is the RGB image, I wouldn't do this on the luminance image. I only do noise reduction once before stretch on the luminance image. Typically don't do it again after stretch. Back in the old days, and I mean going all the way back to early 2023, we used to use, what was it? Multi-scale linear transform before stretch and TGV denoise after stretch. Am I right about that? Can someone confirm those? Nobody?
Yeah, sorry, something like that.
Something like that. Okay. Yeah, so there was a noise reduction step before stretch and after stretch.
Yeah.
And that's been, Russ Croman has subsumed all that. So I would run another noise reduction step here. That goes fairly quickly. And then I'll open up histogram transformation again. And now I can move this slider over some more, this black point slider. Ron has told me try not to clip more than about 1,000 pixels. Given that this sensor is about 4 times the size of the sensors I was working with when we were talking about that, I don't mind if this number goes up to around 4,000. And so that'll help get us a little more contrast. And then I'll just bring the midpoint up to where I like it. It's more or less a matter of taste. And also when stretching the RGB, you have to keep in mind that the luminance is going to have the final say in all of this anyway. So that's kind of how I go through my stretching exercise. I do sometimes use generalized hyperbolic stretch. Sometimes I'll use one iteration of it to just kind of get started, but it's pretty rare. Maybe once every 20 or 30 images, I may run into something where I need that. So, any questions about that so far? So here I can open up.
Not
Go
seeing
ahead.
just not seeing any additional questions at the moment.
Okay. So I'm going to go ahead and run this up to where, run the RGB image up to where I did my stretch on it. So that was my final stretch on the RGB. Luminance, it was a very similar process, very little different. I'll go ahead and run it up through the history until I get to where I finish stretching it. And then the stars are a little different. The way I stretch the stars is a little different. I think we can walk through that bit by bit. And I've heard people who are aghast that the stars would be stretched differently than the image. I don't know. I don't know why that would be a bad thing necessarily. To me, stars are incredibly important. Not a huge fan of starless images. They're okay if that's what you want to do. It's, you know, it's up to you. But I prefer them with stars. But at the same time, in most cases, the stars are not the stars of the show. It's the nebula you're interested in. So I do want to kind of control the presence of stars and make them where they don't overwhelm the image or alter the perception of the nebulosity that's going on. So we'll run through the history a little bit here of and what my goals are. So when I'm stretching the stars, what I'm looking for is to incrementally get to where in the dark spots, I've got between 5 and 10% gray or color. So if I drag my cursor around in a dark spot here on the image, I can see that it's in some spots it says, well, I'm seeing some 5s there. But this is about the range where I want it. Maybe over here is a better spot. Somewhere between 5 and 10, and where the stars look nice. I want them to have, you know, be a nice airy disk and not be splotchy. And so this was the stretch. I thought this worked pretty well. So returning back to the RGB piece, the next thing I'm going to do is run SCNR on this. Now, I'm told that if you use SPCC for color calibration, you don't have to do that. But I can see quite a bit of green in here. I don't know if that comes through on the presentation, but I see quite a bit of green in here. And I'm pretty sure there's not a lot of green in NGC, in the NGC 1333 area. So I'll just use SCNR with its defaults and green to remove that green. I've already done that, so I'll just move through the history there. So now it's got a little bluer, maybe a little more magenta look to it than it did. And next, I will combine the luminance with the RGB image, and I would do that with LRGB combination. And just have the name of my luminance image plugged in here. Everything else is a default. And I would drag that over here onto the RGB image. But since I've already done that, that does take a minute or two to run. I'll go ahead and just apply it. Now that kind of changed the character of it pretty considerably. So whether a synthetic luminance from the RGB would be better, or whether this luminance would be better, I guess, is a matter of individual judgment. But I really, you really see a lot of difference here between what we had before we combined the luminance with the color and what we have afterward. And then I'm done with the luminance master for good. Pretty much done with the RGB master here in PixInsight. One last step here is I want to run SCNR on these stars too, which I have already done, to remove any green from the stars. I don't think there's any green stars out there. Are there? Are there any green stars? And then
I'm not aware of any.
Not
The
aware of
thing
any green
Well, the
stars.
thing about the green is that when a star's color, like the range of all the different wavelengths it emits, when it peaks in the green, it appears white because it's covering enough red, green, and blue to appear white. Wow, that combination of red, green, and blue. That's exactly what our sun is. It actually peaks in the green, but because there's enough, like the shape of the curve of that emission of the different wavelengths, it ends up being white.
Okay.
So that's the reason,
Okay.
more or less.
So you don't object to me removing the green from the stars?
Not at all. I do it all the time.
Okay.
Just be aware that there's yellow in there. You don't want to like mess with that too bad.
True. And after having done that, I will run one more round of a noise exterminator on this. Again, full bore. So with these parameters, 1.0 on this, I want my stars to be nice and smooth and airy looking. And then finally, I'll run star exterminator. This time, I will generate a star image, and I will have the unscreened stars checked, because later on in Photoshop, I'm going to screen them back in. Now you can do that in PixInsight too. There's a pixel math formula that lets you do that, but Photoshop has that built into it. And then again, I will use the large overlap on that. And that takes about 5 minutes to run on this image, so I won't do that because I've already done it here. Oops. And so now I'm going to save these out as 16-bit TIFF files. PNG files work as well. In fact, I have to, when I'm doing a very large mosaic, I have to use PNG files because you run into a TIFF file size limit. I think it's, what is it, 4 gig? Something like that. So I'm going to save this as a 16-bit TIFF file. File save as. Then I click on TIFF and click on 16-bit. And same here. I'm going to do file save as. I'll save the stars. Now I've got these files out here where I had my masters before, and I'll open up the RGB image in Photoshop if I can find it. So the first thing I'll do here is create an image layer. And I know there's a menu option to do that somewhere. I don't know what the menu option is. I know what the keyboard combination is. While holding down on Control Shift and Alt, hit N and then E, and that creates a new image layer. And I'm going to call this PC because I'm going to do precision contrast on it. And so
Tim, it's right
do
at the
that.
bottom. It's right at the
Do what
bottom of
now?
the menu. It's right at the bottom where it says, right down there. So
Right down
you
here.
drag it down, you can add, delete, or duplicate a layer. There you go.
Like that
Click
one.
on that. Yeah, new layer.
Okay. Okay. It's always good to learn something. So then I'm going to go over here to filter, and I have Topaz Studio installed on my machine. This is a really old version. Patrick pointed that out today. This is a super old version. I think it's a 2019 edition. I'm sure this function's still available in it. This is one of those things that ain't broke, so I haven't fixed it. And then I'll run Topaz Studio, not Topaz Denoise, but Topaz Studio as a filter on this. And it'll bring up the image in Topaz Studio. And then I'll go up to Filters, Essential, Precision Contrast. This is the only thing I use from this program. It's the only thing I've ever used from this program. And kind of my starting point is I go between 20 and 30 on the medium scale contrast. And then between 30 and 50 on the low scale contrast. And then kind of the starting point for the micro scale is around 40, although I may go up to 60 on that. Now I'm kind of liking where this is going. I don't want it too much. You don't want too much or it starts to look garish. And so that really brings out those dust lanes and it, you know, helps darken the darks and lighten the lighter colors. We look at the original and then with contrast added. So this to me is kind of the secret sauce of this whole process. Then next I would go up here to adjustments and add an adjustment layer for saturation. Probably won't do a whole lot here. Like this is completely a taste thing. So I want the parts that I want to be really blue, but I don't want some of this extraneous blue that's going on here. So I'll go up here and go to blue and pull that back. And also cyan. I think I just had a guest speaker walk through. I don't know if you could see her. So kind of subdue the blue a little bit here and leave that for another saturation layer. I'll bring that up a bit again. And maybe even go a little harder on the blues and the cyans. And then I'm going to click on that mask. This is a mask for this saturation layer, and hit Control-I to invert it, which means nothing gets through. And I will, I've got my brush tool selected, and I made my brush color white. And so now when I've got this saturation layer selected and I draw here, I can be a little selective about the saturation I'm applying, where I want to apply it to. And of course, I would spend a lot more time with stuff like this if I were really processing the image, but I know you guys don't want to be here all night. And then finally, for this portion of it, I'll add a curves layer, and I will put in an S curve, which will help bring out the contrast even more. Now notice I've got some areas that are, because of all this, have gotten extremely dark, and I don't want certain people on AstroBin to break my back over having black points in my image. So one thing I can do is go back to this precision contrast layer, add a mask to it, make my brush black, and go to those areas where it's too dark because there's just too much contrast, and kind of remove those from being affected by the precision contrast layer. Okay, and then finally, we will just take the stars image and just drag it on top. And then go over here to this little drop down and select screen to screen them in. And then on top of that, I will add a hue and saturation adjustment layer. If I hold down Alt and click on the border between stars and hue saturation there, then I'm only going to be applying this saturation effect to the stars layer. So I'll typically ramp that up between 30 and 60, depending on the characteristic of the stars. And then finally, I don't really care for this orientation, so I'm going to rotate it 90 degrees clockwise. And I think I'm done.
Looking pretty good.
Yeah, that's impressive, Tim. It's amazing what a big impact those contrast adjustments made. That you know, when you brought the image into Photoshop, obviously there was certainly a lot of detail in that dust, but the contrast really changed the character of that dust.
It really does. It adds depth to it. It reveals the depth. I don't know if it adds depth to it. I think it reveals the depth, because that those differences are there. They're just so slight and so subtle. They're hard for our eye to see. And so, we need, not only are our eyes terrible looking through a telescope at an object through an eyepiece, but they're terrible even looking at a photograph. The eyes are not very good at seeing, sadly. So we need help. But I want to try to bring out the natural beauty of the object without falsifying the object. So I hope that's what I've done here. There may be people who think I've gone too far doing this thing or that thing, but I hope not.
Then
So
what kind of profile are you using for this?
what
Do you mean
what
like
do you?
color
I don't know
profile?
what you're.
Color profile.
Oh, whatever color profile it happens to be in.
So if you go to your edit menu and go down to, you can select a profile, which makes a difference. Keep going down. Assign profile towards the bottom.
Assign profile.
Yeah, yes, changing it. So there are different profiles you can use which affect how the colors are displayed. And you're using 1966 sRGB.
Is that good?
Well, the point is, if you put this out as a JPEG and you haven't selected a profile, then it's whatever the monitor of the person who's viewing it is. So when you select a profile, which like sRGB or 1998, then it should display, if all goes well, as you see it on your screen, depending on the monitor. So you should always select a profile.
So which
And
one
the
should
other
I?
one, well, that's one. The other one, Adobe RGB has a different look to it, which I sometimes use. But
This Adobe RGB
RGB,
1998.
yeah. But again, you can click it on. Well, you can click on and off and see what you like. But you should probably do that at the beginning of the processing, not.
Okay. So I learned two things tonight, at least.
And the other thing that's interesting in Photoshop under the filter is, well, you don't have a layer. You can use the camera raw filters.
Yeah,
with
well, I use
double-
that
Oh, I
on.
love camera raw.
Yeah, camera raw has
yeah.
a lot of the functions, and they're more contemporary than our friends at the ones you use.
So sometimes I will use, like, for example, the noise reduction in camera raw on the dark areas. If I've got some faint stuff that just looks really ugly in the background, I may use noise reduction from camera raw on that.
I'll note that the new AI denoising tool in Camera Raw, which I think it's in the 2024 version, is the one I have right now.
Yes.
Then I haven't tried it on an astrophoto, but I've tried it on like regular daytime photos of people, and it is awesome. So
Yeah, there's a lot. Camera raw has really come along. The other thing, again, you're not here to get suggestions, but one thing to consider is
I am here to get suggestions.
To use in adjustment layers, use the vibrance selection.
I love vibrance, yeah.
As opposed to just saturation and balance. Again, you're towards the end in the beginning. So I wouldn't use saturation. I'd use the vibrance as an adjustment layer with appropriate masking, as you've already done. You might find vibrance is a little more a lighter touch tool than just saturation. And it also contains saturation.
Okay.
Yeah, vibrance is certainly a lighter touch, as you said. But the thing is that in the hue saturation tool, of course, where you can target the individual hues and change the saturation, you don't have vibrance as an option there, so you're kind of stuck with saturation in that tool. But
well, in the camera raw filter, yeah, you can. There's some pretty cool.
Yeah, there's a lot going on. Do you have a current version of
Yeah, I should be. I mean, I'm paying like $40 a month for this thing, so
Yes.
I should be all kinds of current on everything. So,
There-
but yeah, I have at times used the color grading piece. That's interesting. And then the color mixer, of course. So yeah, you can, like on these chocolate images, you know, adding some orange saturation seemed to help sometimes.
Yeah, when
Um,
people ask what colors should these be, I always say chocolate. That's that's a good name to remember. If it looks chocolatey, it probably is right.
Now if you want, I could tell you about another tool that Lloyd turned me on to.
Sure.
Sure. That's why we're here.
And it's not, I wouldn't really use it on this particular image, but it's called 3D LUT Creator. And this is what it looks like. And so you've got a color wheel here, and there's a button here, image from PS. And it's gonna grab the picture from Photoshop at some point. Yeah. So now as you move around on here, it highlights the dot on the color wheel that corresponds to the color your cursor is over. So like if I wanted to change the blues, especially if I wanted to change kind of the darker blues, I could click on this dot and that locks in the points on the outside of it. But now I can drag this thing around to any point on the color wheel and affect that color individually.
Yeah, that
This
looks
is-
pretty nasty, doesn't it?
Well, that looks terrible, but there are some good applications for it, especially like controlling star halos that are out of control and things like that. There's some pretty good applications for it. And then when you're done, you click on LUT to PS, and it puts in this layer. LUT is a lookup table. LUT.
Oh, yeah.
And so it puts this layer in that you can turn on or off. And so it's more useful for narrowband than it is for broadband probably, but again, there are circumstances where, like, if you've got star halos that are out of control and you want to soften them, or you want to change the tint of those star halos, that's a pretty useful tool. And it's especially, I think, ingenious with the interface being the color wheel and moving things around on that color wheel. So that was just something Lloyd called his secret weapon. Now it's not so secret.
Yeah,
I
that's an
tried to
unusual
buy it.
application of that tool. So usually I think of those tools as more of a video thing, but obviously you can use it here in Photoshop. So
Yeah.
Oh, I see there's a question here from Norm. It seems that Topaz Studio is not around anymore. If you have a license for Topaz Studio, you can call them up and they can restore it. But it's not, I don't think they sell it anymore.
And I think this precision contrast tool is available in one of their other newer applications.
Yeah, Topaz always wants to sell you new stuff.
Absolutely. I can ask and get back to you guys, because the guy who owns Topaz Labs lives down the street from me.
Oh my gosh.
Hey, can you get him on the show?
Yeah, actually.
I've tried, if you can get him on the show, I'd like, if you know him personally, why don't you ask?
I'll ask him. He's a very shy person, so I don't know, but I can ask him. He has told me numerous times, we do not make this for astrophotos. This is not for astrophotos.
Yeah.
Yeah.
And I
Okay,
said,
thank
why
you.
not? And he said, well, what is the market for astrophotos? Like 200 people?
No,
We could
5,000.
make hundreds of dollars a year selling tools to Astro people.
Well, Astro
So-
people are buying their tools. So tell them there's 5 to 10,000 astrophotographers.
Okay. So he can pay rent on his office for a month. He sells us all something every year.
Yeah, unfortunately, we're pretty niche when it comes to that type of thing.
Yeah, we're not going to get a lot of love from anybody. It's hard to get love from our own vendors sometimes.
At least Russ Croman loves us.
Yes, he does, and we love him too. So
In RC, we trust.
Yeah, absolutely. Absolutely.
All
Any
right.
other questions, comments? Again, I appreciate the tips. Let's see, what was it? Vibrance, and then what were the other things you suggested? Vibrance
I don't know.
versus saturation.
As an adjustment layer, right? I would use vibrance.
Yeah.
And
And then
you want to make sure you assign a profile, and there are different profiles. And then of course camera raw, but you already know about camera raw.
There's a comment
Yeah.
here about Adobe RGB versus sRGB from Victor Beer. So he says that Adobe RGB is a wider profile, which may not display all the colors accurately on the web or Zoom. So he usually assigns sRGB instead. I don't know much about color space, but that's something from him.
Me either.
Well, whatever you do it at the beginning of your Photoshop processing. So you see the results, and it works better for some images versus others, the two profiles. It's a tool, not a rule, remember.
Victor's correct. The gamut is not as large. You should always shoot for the lowest common denominator.
Okay.
Otherwise, you'll get something that looks completely wacky on someone else's computer. It will look correct to you.
Yeah.
Yeah.
I want to toss into that images where you get that 3D effect, like you've managed to achieve here. I think that's like the goal. I think for having a good astrophoto, and one of the goals is do you get that 3D effect? Because I think that makes a really compelling image.
Well, I can tell you that the best way to get 3D effect is gather more data. You can fool around all you want on Photoshop, but in the end, the more data you have, the more dimensional the image will look.
Yeah, because if you don't have that data, this precision contrast tool isn't going to do much for you.
Well, it'll do something, but you may not like the result.
Right. You may not
more
like
data. So instead of 10 to 12 hours, try 40 to 50. You'll get more depth to your image.
Yeah.
By the way, I see the cats came back, Tim.
Oh yeah. They're never far. They're never far.
Yeah, mine's sleeping over here on the heater mat.
Well, you're absolutely right, Molly, about the three-dimensionality of this image. And Tim and I were talking about that earlier. And so I would encourage anyone who's watching this to go look at this image on Tim's AstroBin page, because you can see it a lot better. Obviously, you lose some of the resolution and whatnot on YouTube. So, but it is quite nice, and it does have that 3D effect where some of the parts of the image really feel like they're sort of popping off the page or screen at you. So definitely worth a look on this AstroBin page. And Tim has a lot of other great stuff too on his AstroBin page. So
I'm gonna link it.
Patrick, can we it's a beautiful picture and I like seeing it, but can we stop sharing, Tim, so that we can see whoever's talking? Thanks.
Absolutely.
all right. Oh, you're gonna put that in the
Yeah,
chat, Molly?
I just linked it. Yeah.
Perfect. Thank you.
Okay, thank you.
All right. Well, I think we got all the questions. So Tim, thank you so much for being here tonight and doing that demonstration. That was real helpful. So it's always neat to see, a lot of us, we have similar processes, but then we diverge at different points, and it's always really, at least for me, helpful to see where others go, where I might go one way, somebody else goes a different way. And so that's really valuable. All right. So
I agree. Well, thanks for having me, and I appreciate it.
That was great. Thank you.
absolutely. All right, everyone. So join us next week for Alistair Simon's Mosaic going to be really neat to see how he put that thing together.
man.
So,
Yeah, I can't
and-
wait to see that.
Yeah, and Tim, you can stick around after the show if you want.
Okay.
All right. Well, we are out of here. So good night, everyone.
Good night.
See ya.
Right.
Have a good night, you all.
Night.